Namaskar. This is fourth part of GeoGebra tutorial. First three parts, I hope you have liked it. I'm using GeoGebra Classic 5. 6.1 is having more facilities, but then the interface is smaller, so I don't recommend that to be used. Now today, let us start with the command for creating a list. So what we have supposed to do is, you are supposed to enclose the list in curly bracket. So start a curly bracket and go on entering the elements separated by comma. So let us say 1 comma 2 comma 3 comma 4 comma 5. Okay. Now once you enter this, the list will be generated. So we have this particular list. Computer will name this as L1. Now your number of processes on the list. So you can have sum of the elements. Okay. So if you write here sum, then what you have to do is you have to take that list and let me say L1. So it will give the sum for this entire list. So you have this 15 as the sum. You can see this 5 plus 4 plus 3 plus 2 plus 1 is 15. If you want a partial sum, again we say sum, and then we can take this list and number. So L1, and maybe I take sum for the first three numbers. I enter, I get that sum, 3 plus 2 plus 1. Okay. Now the list is used for other purposes also. So one of the purpose is a best fit line. That is, you are given some readings and through that we want to pass a graph which will show us the best fit of that graph. So what I do is I go on clicking some reading points. Supposing I plot this on a graph paper, okay, and then I want what is the best fit for this line. Okay. So what we do is we first generate this list here. So we enclose and then I say A comma B comma C comma D comma E comma F. So I have generated this list of these points. Okay, and then what I do is I enter. I got this L2 as a list of these points, and then we say best fit line. So we have here, you can go here and see you have got this best fit line. Okay. Click this and then click this particular list. See, you have got this particular line. Then you can decorate if you want this particular line to be decorated. Now see how this is the best fit line. That is, I move any of these points, you'll see, and the line gets affected. See, this line gets affected by any of these points. Okay. So this way it's possible for you to see that yes, it is a best fit line. Okay. Now we take another utility in GeoGebra, and that utility is dilation. But before that, I will remove this junk. So I just delete this. I delete this also. Right. Now, for dilation, I take a triangle. Okay. So, let me take a triangle here. Something like this. We have got this triangle. I want to dilate this triangle. Okay. So, we put here command dilate. So, I choose this. Name of the object is T1. So, I say T1, so not capital T1, and the dilation factor. Let me say dilation factor is 2. Okay. So you'll see that this triangle, all the sides are getting multiplied by 2, and we get this particular triangle. Okay. Now what we do is we say enter, and you got this. A has gone to A dash, B has gone to B dash, and C has gone to C dash. Now, supposing I have this particular point origin as D, then if I connect the AD, let's say DA, you will see that the A dash is in the same line, and you will note that this 2.83 is the distance DA, segment DA, and 5.66 is the segment DA dash. Similarly, all these segments will be doubled, and this particular figure will be generated. Okay. Now, let us see the area of these two triangles. You'll see that smaller triangle has area 2.37, and the larger triangle is having area 9.49. Now this is exactly 4 times the area of the smaller triangle. So this way possible for you to see that dilation works in this particular fashion. Okay. Now I have not stated any dilation point, but if I state a dilation point, then that point will be taken to dilate the object. Okay. Let us see that. Okay. So for that, what I'll do is I'll delete this particular triangle. Then I can delete these. Okay, I'll take the new triangle altogether. Okay. I delete everything. Now I take a triangle again, something similar to what we had taken last time. And now let me say that I am dilating this about some point, let's say A itself. Okay. So we say dilate, and you see that you have the dilation factor and dilation point. Okay. So object is T1. Dilation factor again I take 2, and dilation point I take as A. You will see that this particular triangle is now double. Now if I change this particular point, maybe that I take some point here, and then I delete this, and I take again dilation, object is T1, dilation factor again let me take 2, and now point is D. So I got this triangle. So you get similar figure by dilation. Now there is one more facility known as rigid polygon. Now let us see what is the use of that rigid polygon. So what I do is I take rigid polygon for this particular triangle. Okay. So what we do is we say rigid polygon, and I want this for T1. So I got this particular triangle. Now it's possible for me to move this triangle at will anywhere. You see that this is a copy of that particular triangle. And then if I want to check the similarity or congruence of this triangle with any other triangle, this can be taken there. So I take this, see this angle is exactly matching, here the angle is exactly matching, here the angle is exactly matching. Now if by chance you have to check one triangle which is not, having the parallel sides, then here there is a facility of rotating this triangle at will. So with this F, I can rotate the triangle, and with E, I can move the triangle. So supposing this triangle was inclined, then what I have to do is, I have to first match this point and then rotate this. So this is the use of this rigid polygon. Now in this itself, I will show you the midpoint tool. Okay. So this is a midpoint tool. So for any segment, if I want a midpoint, I just click, I get midpoint. I click here, I get midpoint. So this is a very useful utility to get the midpoint. Another interesting application or the facility is that you got a point on object. Okay. So I put a point here. Okay. Now this object, this J is on this object. So if I start moving this point, you will see that it is bound here in this particular figure. It cannot go out. It remains inside this. It's a very, very useful thing, especially in the optimization problem. This point on object is very useful. If you want to deselect that, then you have some facility, point on object, attach, detach. So if I say detach, then this particular point I should be in a position to take out. Okay, so it's possible for you to attach or detach that particular point. Now we'll see one more application, but before that, let me show you that I doubled this triangle in the sides, so the area should be, see, 2 square, that is 4 times. So you'll see that area of the small triangle is 3.12 and area of the large triangle is 12.48. So this is exactly 4 times. Now I delete these things. Okay, I delete all these points also. Now I will going to show you the extremum function. Okay. So showing extremum function, I have to plot some function here. So let me take some function. Okay, let's say x cube. You see immediately the cubic function comes. Okay, and it has this point of inflection at 0. But I add some more terms to that, maybe minus 3x square. Okay, right. And again I add one more term, say x, and I want to shift that up. So I say plus 1. Okay. I got some function here. Now this particular function, I want to see what are the extremum points, that is maxima and minima. So you just go here and say extremum. for polynomial. Okay, so this polynomial function name is f. So you see that you have got these 2 points. This is the local maximum, this is the local minimum. This particular function has global maximum as infinity, global minimum as infinity. But we are interested in these maxima and minima. Okay. Now, here itself, it's possible for you to see the roots of the polynomial. So for that, what we do is, we have got to have the intersect function. So intersect of this particular function I want with x-axis. So we have got these 3 roots, that is C, D and E. These are the roots for this polynomial. Okay. So this is how GeoGebra comes handy to you. I request you to get into this GeoGebra and solve your problems and understand those very well. Okay. Thank you very much.